activities, because being engaged is important, being in the moment is important, but also having a record of these. These are permanently in there for you. Of course, you're allowed to use these.
Because when we did it in the school, we didn't have the books or anything, and I'm just thinking back to how boring. I actually felt kind of sorry for the kids because I found it boring, even just like trying to tell it. With this, it's so much more like you're actually paying attention to it.
And it's not an iPad. Why is it not an iPad? Why don't I just flick through on an iPad?
I can tell.
What's that?
Sorry.
There's no like sense to it that you can, like swiping through. You've got no connection to it.
Yeah.
It feels like an own creation. So it looks like someone has
Taken
made
the
it,
time.
and the kids feel like, oh, I can make my own story now.
AMI, by the way, you colour in 5 of those things, and you colour in every single one of these charts.
Rachel had them in big,
Yeah.
like hand-drawn, laminated
Oh,
ones
yes.
that she did it with.
Yeah.
I just want to say I'm glad that you stopped where you did, because I'm really tired and I don't think I could have taken in much more than that. Like I was beginning to zone out, I was really interested. I really wanted to listen, but I was having trouble listening to more.
As I say, there's a lot more, and
Yeah.
I'm going to go a lot faster, so let's just think how we're going to manage that.
I just will.
You'll get there. All right. So,
But I mean, just taking a break from listening to a story.
we'll talk about it, yes. So, can you understand story? Can you see story being demonstrated? Can you understand? So, it would be hopeless if I just told you the story and nothing. We need to have those imaginistic charts. Now, they're simple. They're not. The imagination must be engaged, okay? An iPad showing a photo of the universe would be meaningless because there's nothing left for you to imagine. You have to give them the least necessary support. You've heard me say it, and now I'm asking you to say it, do it in these charts, okay? It's not a perfect picture of the sun. It doesn't have it's just showing scale. That's all it is. That little black dot is what this whole picture is about. And if you didn't know that, this picture would be meaningless, right? You'd think, oh, somebody's left something on the photocopier. And this is why people say, oh, give me a copy of the charts. I'm like, but you won't know how to use them.
Go make your own charts.
There's a lot of these charts. Okay, all good. So the sun and the planet, it's called the sun's family. It's called hot and cold, or the dance of the angels. The obscured planet, the sun's beautiful daughter. Inside our planet. And thank you to the sun. That's what they're called, right? So they have all of this lovely energy with them. Okay. You ready for me to move on? I'm missing 2 steps.
Shona and Jenny.
So all of these, pretty much, each card is a story. So we looked at timelines being one way of presenting information. Now we're presenting the information in a different way. Timeline is meaningless unless you have done the vertical and horizontal studies first. You have to show kids how to put a timeline together so they get how it works. And that's why we start off with events in a life. For a very young child, you have a picture of breakfast and lunch and bedtime and bath and story time, and then they put the pictures in order. They have to be able to do that process so they get it. What was yours? Oh, okay, I can wait. I'm just sort of pausing a little bit. Maybe that's not going to work. This story is about the sun makes this half of the planet hot, but this part that is in shadow gets cold. Do you know it gets cold at night, but it can get hot during the day. The side of the planet that is not facing the sun gets very, very cold. Being in the shadow, so you've taken them on camp and you experience that falling back. When you're in the shadow of the planet, the shadow side, it gets cold, but the sun side gets really, really hot. We couldn't live on this side of the planet because it would be too hot. We couldn't live on this side of the planet because it would be too cold. I wonder what our planet does. Our planet keeps on turning. And it turns and it turns and it turns, and so that we know that the hot side gets cool at night and the cool side gets warm during the day. This picture here shows us that the sun is directly ahead at noon, and this is what says noon here. Over here, if a little person was standing there, the earth revolves around and the little person as the tip of my finger pops up to be seen by the sun. We think the sun is rising, but we know that there's the little human. We call this dawn. And the light is not as dark when there's some light coming from the sun. And after lunchtime, which is noon, it goes through, and then we have sunset. And then the little person falls back round, rotates around like this, and it looks like the sun is setting, but actually we know the sun is constant relative to the earth. Noon, sunset, midnight, dawn. Make sense to everybody? Does anyone want to comment on the understanding that you're getting from just these very simple charts? How does it feel as a learner when I present this idea to you like this? Is it easy? Straightforward? Is it satisfying? Have you ever shown a child how dawn and dusk worked before? Do you need coffee? Well, we can break if you want to, but I'm just really conscious that there's so much to do. When the sun comes down on Earth, we know that the planet gets hotter and hotter and hotter. If you stay under the sun, you get hotter and hotter and hotter. And actually the hottest part of the day is around 2 o'clock. You can see that this has got a red indicating heat here. It does start to cool off. And then at night, we've already talked about it being cold. And slowly it warms up as the heat from the sun comes on the planet. And these are all times, 12 o'clock, 1 o'clock. What's this, 13, 14, 15? We know around 2 o'clock is the hottest. So around this sort of time in New Zealand, we have a sunscreen morning. This is when you're most likely, and you also see that the sun is closest to you. Where over here, the sun is a long way away, but here it's closest. This means that you need to wear sunscreen or whichever appropriate device you need to do to protect you from the sun. Here you can see. When you look at it, you have no idea what I'm talking about. As soon as I tell you the story, you go, I know exactly what it is. The sun's energy rays are coming to this small patch here. Very intense, the same number of rays, 1, 2, 3, 4, 5. These 5 rays focus on a very small area. So around the equator, it's very hot. This is a pole and this is a pole. We have a hot area here, not so hot here, but quite cold here, because the same 5 lines, when they come from the sun to this area, are spread over such a big area. The intensity of the sun's rays is a lot less. And although it looks like a long distance, it's not really, but it is slightly further away. Remember, the sun has come 93 million miles, so this 20,000 is not significant. But it does look a long way away, but you can see that it's spread out. The same intensity of light is spread out. So very intense light here. And you'll see later it doesn't have to go through so much atmosphere. The sun is coming down, and it comes down straight on top of you, like at noon, like we're saying, in the equator. The sun's coming straight down, and you see that this area has got a lot of light spread on it. But if I spread it out over put it on an angle, I've spread out how wide. It's the same. So that when it's on an angle, it's not as intense. It doesn't get as hot. Here's the same idea again. This is the planet Earth. The yellow is the planet Earth. Then we have layers of atmosphere. Do you know the song Twinkle, Twinkle, Little Star? Stars don't twinkle. Stars just radiate light. They look like they're twinkling because the shifting layers of atmosphere when the sun is straight above us, it only has a little journey through the atmosphere to go. It's like we're trying to walk through really thick mud. This is only a little trip. It's quite fast to get through. But when the sun is on an angle, it's got lots and lots and lots and lots of layers of mud, of thick atmosphere to get through. So it's a lot weaker. The light is a lot weaker. The moon, when you see it straight above, looks small. But when you see the moon through this magnifying glass called atmosphere, it looks really big. Sometimes you see great big yellow or red moons. That is because of the dust in the atmosphere refracting and making the moon appear a lot bigger. So I said before that the difference between here and here is not really significant. So 1,000 miles or whatever it is, it's not a big deal. But this is slightly closer. I remember that's 93 miles, so it's not really big. But you can see that the light at the equator is closer. Here you have some pictures that help us to understand how seasons work. The sun sends energy to the earth at different times of the year. Here, it's sending the sun. And the energy is arriving to the bottom half of the planet more than the top half. This means the bottom half is in summer and the top half is in winter. Because of this tilt, we wouldn't have seasons if our planet was perfectly perpendicular to its range of motion. But because it's on a bit of a tilt, this bottom half gets more sun sometimes, and therefore we call this the southern hemisphere's summer. But at the same time, the top half of the planet is not getting as much sun, so it's the northern hemisphere's winter. Whereas at this place here, and remember that the tilt of the axis always is the same place, so it just does this all the way around. It doesn't change, it doesn't revolve like this around the planet. Around the sun, it always stays pointing actually like that, pointing to the North Star actually. There always. It's a celestial North Pole. So on this side, my fingers are closer to the sun. Let's say the sun is over there, and my elbow is far away. Like on this side, when the sun is over there, you can see that my elbow is closest because it's the same. So remember that we have this 27-degree tilt, which gives us our solstices and equinoxes, which is what we've got through here. Do you remember what an equinox is? Equi, the same, nox, night. Equi, the night, is the same length as the day. Do you remember what a solstice is? A winter solstice or a summer solstice? A solstice sounds like the sun is staying still, i.e. the sun almost doesn't set in some parts of the world. The sun just stays still. Things go up and down. It doesn't set. The same, the solstice means sun still. Equinox means equal night, equal day. So, this says north, this says south. So we're on a tilt like this, and we're going around, the Earth goes around the sun. This is a summer solstice because this is a summer solstice for the southern hemisphere, and this is a winter solstice. The autumn and the spring equinox. And it's exactly the same length of time. So it's the days are getting shorter and shorter and shorter and shorter and shorter. They're exactly the same now. And the night and the day are getting, and it's still getting shorter and shorter and shorter and shorter. And now we have long nights, short days. And now they're getting longer and longer and longer and longer and longer. They're the same and getting longer and longer and longer until we get to the solstice. If we cut open the Earth, you would see inside A little bit like when you open a chocolate, you can see inside that there's other layers there. On the outside is the layer we're used to seeing in pictures, but we know that this is plastic mantle. Plastic just means that you can change it. And solid crust. When you're talking about plastic, when we talk about plastic, we know that all comes from petrol, and we know we can shape it any way we want to. That's why it's called plastic. We can make it hard and soft, or like your drink bottle, or like your drink bottle, and make quite different. That's what plastic means. When we are thinking about our Earth, we need to understand that in here's the plastic mantle. This is the part that's all moving around and hot all of the time. And then we have these great solid areas on top. Sometimes a little crack comes through, and this little crack means that the hot, remember we talked about the hot rising up, and when the hot boiling magma inside finds a little crack like that, it'll find a way up, and boom, and we get a volcano. You know, the world's biggest volcano is right here in New Zealand. And Lake Taupo is the crater of the world's biggest volcano. It doesn't live anymore. It used to be. And although it hasn't burst out lots of lava for a long, long time, it hasn't erupted for a long, long time. When it did, the whole of the world got covered in ash. And they wrote a story about it in China, about how it was all dark. And then years later they realised that it was all dark because Taupo exploded. You can see here that there are some pressures on a river. The water is pushing down. Water's really heavy, isn't it? You try carrying water, and if there's lots of water, it pushes down a lot. So the water puts pressure on the land beneath it. That land squashes out and puts pressure on the land beside it, sort of like this dough I've got. And if you push it down, you'll see it comes splurging out either side, which pushes up these mountains. And then all of these layers are exposed, whereas it used to be flat across like this. You can see that the yellow is now bent around. And all of these have got. When you push something up this way, then something else needs to come. So we understand how land forms. Land starts off, all layers are parallel, and then all of those pressures happen, makes the land different shapes. You know, you've got hills or valleys, you might live near some mountains. And you can see that when we take away all of those layers, we're left with different shapes. And sometimes when the mountains are covered with lots of soil, we can't see the different shapes, but when we just see the rock, it's quite stark. New Zealand is one of the newest countries in the world and has mountains that have not yet finished being fully weathered. Here you can see the layers of rocks, some of which have been pushed up and some have been pulled down, and these are called valleys. These are called mountains. We know that they used to be all connected up because this yellow rock here used to all be in one line. And we know that it's been pushed up. I wonder what pushes it up? It's the moving plates. But we can still see the same patterns. But sometimes they get pushed up and moved sideways or pushed up and moved around. How are we going on your brains? How do you think? Is it interesting for children?
Interesting.
Yeah? Is it useful? Yeah? So this is something, I mean, there's so many of them. You're never going to do what I'm doing now. You're just going to sit down 2-3 minutes with each child. Hey, this is it. And then there's so much work that they can do. But if somebody mentions hill, somebody mentions hot, somebody mentions anything, you've got a wealth of resources to refer to at any time. All of these charts, by the way, are on your AUT Online. They are under charts, I think. You're welcome to print them out when I say that, I have to be a bit careful. I have signed a piece of paper in my past that said I will never put them online and I will never allow other people access to them. It's the copyright material of AMI. They are not my specific charts. They're somebody else's. Mine are still in my aura, I think. I left mine in my aura because I set up the Purity room like 100 years ago. So mine are still there, but these are somebody else's. But technically you shouldn't, because this is just like using somebody else's lyrics of a song and calling it your own. What